Hello students, a warm welcome to all of you in ITLS Academy and also welcome to all in our 3 months online certification course on topic nanobiotechnology. In today's lecture, we will discuss about the microcontact printing. Okay, now we start today's lecture. First, we discuss what is a microcontact printing. Okay, microcontact printing is a technology for surface patterning. Surface patterning at both micro and nano scale. This technology is invented by Kumar and Whiteside in 1993. This technology has been extremely used across the diverse field of science, engineering and technology. Basically in nanotechnology and material science. Microcontact printing is widely used in nanotechnology and in material science to create the nano and microsporic pattern onto the surface or substrate. Okay, basically in this technology we typically involve a stem with a desired pattern that is pressed on a surface coated with a material, often thin film of polymer or a metal. This method can be used for various applications such as fabrication of electronic components, sensors and even biological assay. Okay, now we understand the process and principle of micro contact printing. Okay, now we understand the working of micro contact printing. Okay, in this process, first we will take a stamp. This is a stamp. This is a stamp. Okay, now we spread out the ink onto this stamp. Okay, we spread out the ink onto this stamp, and after the spread out process, evaporation process will perform. Evaporation process will perform. In this evaporation process, solvent is evaporated. Solvent is evaporated, and only a thin layer of ink is remain on this stamp. Okay, this is a ink. Okay, after the evaporation process, a thin layer of ink is remain onto the surface of stamp. Then we press this stamp and ink onto the substrate surface. Substrate's surface. And this is a surface. Okay. This is a ink. Now this is a stem. This is a ink, and this is a substrate. Okay, due to this physical contact, this ink is transferred stem to substrate, and this printing pattern is imprint onto this surface. Okay, and in this surface 2D structure will form. 2D structure will form. Okay, this is the whole working of microcontact printing. In this process, first we'll take a stem, then spread out the ink, and this stem contain our desired pattern. Then we spread out the ink onto this stem, and then we perform evaporation process. In evaporation process, solvent will evaporated. After the evaporation of solvent, a thin layer of ink will remain in the surface of this stem. Okay, then we place this stem onto the surface of substrate. Then due to this physical contact, this ink is imprint onto the substrate and create the 2D structure. Okay, this is the working of micro contact printing. To perform whole process, there are a certain interactions are responsible, but three interactions are most important. First interaction is ink stamp interactions. Second interaction is cohesive force among the ink ingredients. Third interaction is ink and substrate interactions. First two interactions, that is the ink stamp interactions and cohesive force among the ink grade ingredients is responsible for inking the stamp. And third interaction, that is the ink substrate interaction, is responsible for transferring the ink from stamp to the substrate. Okay, rather than three interaction, many interaction also work to perform this whole process, and these interactions are non specific interactions. For example, van der Waals interaction, electrostatics interactions, hydrophobic interaction, to high to highly specific antigen and antibody, and binding and base pairing between the complementary DNA. Now we understand the key element of micro contact printing. There are three main components. First is a stem, second is a ink, and third is a substrate. Now first we understand what is a stem and which types of solid material we will use as a stem. Okay, in for the formation of stem, we use for the formation of stem, we use a solid material that allow carrying a substrate and releasing it, while contact can be used to prepare as a stem. Okay, which types of material we use as a stem? The material which have which have two main properties. First is the first property is carrying capacity, and second is a releasing property. A solid material which contain these two main property, then this solid material is used as a stem. Okay, why these two properties are important? Because this stem carry a material that is known as a ink, and this stamp is also responsible to transfer this ink on the substrate or another solid surface. That's why the material of stem contain these two main important properties. Okay, various material has already been used for this purpose or for the stamen process. But there are a lots of material are available in the market which already used for this purpose, among which we use the polydimethylsiloxane, that is known as PDMS. This PDMS is a solid material which commonly used as a stem. Okay. Now we understand the property of PDMS. PDMS is commercially and easily available. This is a first property, and this is easily affordable for the regular labs. Okay, the most important and commonly used PDMS is Shiliod 184, and this is prepared by or manufactured by the this PDMS is elastomeric with young modulus of PDMS around 1.5 megapascal. It is soft enough to allow conformal contact between the contact surface and even the relative rough substrate, but is still stiff enough to reproduce the pattern of stem feature in a sub-micro or nano range. Third, it is a chemically inert or thermal stable. Fourth property, PDMS is a hydrophobic material with surface energy around 20 argon per centimeter cube. Due to the low surface energy, the it easily allows the dissociation of ink from the stem during the printing. Okay, it also play a critical role in the selection of ink material and solvent and the formation of ink pattern on the stem. Okay, this and fifth property is PDMS is a transparent to visible light, which is useful for the process controlling such as aligning a stem on a substrate via the eyes and microscope. These are the five most important property of PDMS. First property is it is easily available and affordable. Second is it is a elastomeric compound. Third is it is a chemically inert and thermal stable with low surface energy. Okay. Fourth one is the surface of PDMS is hydrophobic in nature. Okay. PDMS is a transparent compound. It is a transparent compound. Now we understand the alternative step material. In parallel to development of novel PDMS material and new method for modification of PDMS surface, efforts has been made to develop the non-PDMS material, mainly to overcome the problem or mainly to overcome the drawbacks of Silgard 184 PDMS. There are some certain drawbacks of this Silgard 184 PDMS, and these drawbacks are low modulus, hydrophobic surface, and contamination caused by the uncrossed linked siloxane fragment in the stem. Okay, we understand the ink and substrate. First is the self-assembled monolayer. For this process, we use the alkaline thiol, and this is the first ink. This is the first ink material. Okay, and why we will use this material as a ink? Because it easily form the single assembled monolayer. Okay, it easily form the single assembled monolayer on the metal of gold, silver, copper and lead. Okay, in the process of printing this thiol, in the process of printing the thiol single assembled monolayer, the thiol molecule will self assemble in order to form a monolayer within a millisecond of contact between the stamp and substrate. Why this material is used as a ink in the micro contact printing technology. Okay, we understand the second one, that is a oligonucleotide. Considerable effort has been devoted to use of microcontact printing to produce the oligonucleotide microarray. Since oligonucleotide is a highly negative compound or negatively charged at neutral pH. Okay, whenever we use this oligonucleotide as a ink, then we coat the stem and substrate with positively charged aminosilane. Why we will coat PDMS stem and substrate with a positively charged aminosilane? Because we want to enhance the adhesion property between the oligonucleotide and stem or substrate, or between the ink and substrate and stem. Now we discuss the high molecular weight DNA. High molecular DNA molecules are not major subject of biomedical research, as well as a very useful material for nanotechnology, and plays a most important role in biomedical as well as nanotechnology, and contain a lots of application in these fields. Okay, bio DNA can be stretched and immobilized on a flat of PDMS stem surface and transfer on the substrates by contact printing. Okay, now we discuss the protein. Using an unmodified PDMS stem, printed polyclonal chicken immunoglobulin and alkaline phosphatase on a glass slide and polystyrene disc. Okay. Similarly, Lagov and Chow-Lagov printed primary immunoglobulin G as on glass treated with oxygen plasma. This printed protein layer had a higher density than prepared by the conventional method. Okay. Now we discuss the peptide nucleic acid carbohydrate. Okay. In 2011, a scientist named Calavretta and his colleague printed the synthetic peptide nucleic acid on a glass surface. Okay, the peptide nucleic acid has an amino, and the glass surface was grafted with the aldehyde group. This peptide nucleic acid contains amino group, and grafted sentence contain aldehyde group. Okay. Next, polyelectrolytes. Polyelectrolytes are a polymer that can be ionized and changed in air aqueous solution. Polyelectrolytes are the type of polymer that can easily ionized or changed or Next we discuss polyelectrolytes. Polyelectrolytes is a type of polymer, and these polyelectrolytes can easily ionized or charged in aqueous solution. Printed polyethylene amine on substrate coated with anhydrous terminated self-assembled monolayer. Okay. Now we discuss the conducting and not semiconducting polymer. Conducting and semiconducting polymers are essential material for building organic and optoelectronic devices. Okay, printed 50 nanometer thick semiconductor polyhexyl thiophene film on a various substrate to enhance the adhesion both the ink on the stem or substrate surface. were treated with the oxygen plasma. A thin film transistor was constructed based on the printed of 3 P3HT film. Okay. Next, dendrimers. Dendrimers is a type of nanostructure or nanoparticle. Is a type of nanoparticle. Dendrimers are the synthetic polymer characterized by the monodispersed hyperbranched molecular architecture. Okay, dendrimers have a high density of end group which allow the multivalent interaction with substrate. Okay, in addition, high molecular weight of dendrimers are the resultant low diffusivity allow the high resolution microcontact printing. Okay, next we discuss the nanoparticle. Nanoparticles are in nano-sized structure has widely range of application. Next, carbon nanotubes. Carbon nanotubes poses a unique set of characteristics and terminus potential of numerous applications. In this method, a aqueous solution of surfactant stabilized single-walled CNTs were applied of a rotating PDMS stem. In this technology, we will use the rotating stem, rotating PDMS stem with organic solvents such as methanol for removing the surfactant. Okay, as a result, a thin film of single-walled CNT formed on a stem and was later printed on a substrate. Thin layer transistors were built on a printed single-walled CNT pattern. Okay. In this method, firstly we take a solution of single wall CNT and surfactant surface tent. Okay, or in this technology we will use the rotating PDMS stem. Okay, with organic solvent. And organic solvent, what is the functioning of organic solvent? And the functioning of organic solvent is to remove this surfactant. Okay, as a result, a thin layer of single wall CNT remains on the surface of stem and later on printed on a substrate. Okay, now we discuss the application of micro contact printing. Okay, now compared to other micro and nano fabrication techniques, micro contact printing is featured by the capability of large surface area, high resolution, low cost printing of broad range of functional material on various types of substrate with relatively high resolution and reproducibility. Okay, micro contact printing, moreover, most processes do not involve harsh conditions such as high temperature, high energy radiation, high reactive chemicals that are unavoidable in some major micro and nano fabrication techniques such as photolithography and electron beam lithography. But in these techniques, we does not require these harsh conditions. Okay, microcontact printing, nanoprinting, lithography, and hot embossing as a result has been used for wide applications ranging for nano and micro fabrication of functional devices, study of cell biology, preparation of microarray, production of microparticle to fabricate the materials. Okay, now we discuss these application in the metamaterial. In 2011, a scientist Chadda and his colleagues first time used the microcontact printing to fabricate the large area negative index metamaterial, which are engineered structure of optical properties that are not present naturally. First time these techniques is used to fabricate the large area negative index meta material, or these large area negative index metamaterial is a type of artificial material, and it contain a optical property. It contain a optical properties, or it is a type of artificial material. Okay, in this method they used a silicon wafers with deep nanoscale pattern as a stamp. This technology we will use the silicon wafer with deep nanostructure as a stamp, on which alternating layer of functional material such as silver, magnesium fluoride was deposited as a ink. The multi-layered ink could be printed on the rigid and flexible substrate to form a piece of metastructure as large as 75 centimeter square. In this technology, we will use the silicon wafer with deep nanostructure. ये हम use as a stamp. Okay, this is a stamp. Now silver and magnesium fluoride as a ink ओके, और सबस्ट्रेट के लिए फ्लेक्सिबल या फिर फ्लेक्सिबल एंड रिजिड और फ्लेक्सिबल surface as a substrate. Okay, and finally we imprint the next application that is a microparticle. In 2006, a scientist Guan and his colleagues applied this microcontact printing for producing the microparticles for drug delivery application. Okay, in 2000, in 2006, a scientist Guan and his colleague applied this microcontact printing for producing the microparticles for drug delivery application. They demonstrated fabrication of microparticle with well-defined size and shape using the PLGA, which is a biodegradable polymer used clinically for drug delivery. In this technology, we will use the PLGA as a drug delivery. Integrated microcontact printing and layer by layer assembly technology to produce the microparticle of polyelectrolytes. They generate the microparticles with arbitrary 2D shape and various structures. This approach in principle allows to produce a particle contain a wide and variety of functional materials such as DNA for gene therapy, polyelectrolyte for condensed DNA, enriching the cellular uptake, protein for various tissues target, quantum dots, magnetic particle for imaging, and polymer coated for increasing the circulation time in the next application, that is a microarray. Due to the low cost nature of, there has been tremendous interest using the microcontact printing for manufacturing the microarray. Notably printed DNA for detecting the genetic mutation in yeast. It was demonstrated that fabrication of microarray of pNA, that is a peptide nucleic acids for detecting the single nucleotide polymorphisms. Okay, a method was also developed to replace the prefabricated DNA microarray at low cost. In addition to nucleic acid microarray has been used to create the antibody microarray, carbohydrate microarray, glucopolymer microarray, and fluoromicroarray for ion sensing. The ability to pattern the cell also promising to develop the cell-based microarray for high throughput screening of disease, drugs and toxins. Okay, now we discuss the next application. Now we discuss the next application, that is a functional device. Many functional devices has been constructed based on a microcontact printing. Microcontact printing produces a conducting microcoil by printing by printing by printing single self-assembled monolayer strip around the metal-coated glass capillary and etching away the uncovered metal. Okay, they domesticated the use of microcoil for high microcontact printing resolution, nuclear magnetic resonance spectroscopy of nanoliter samples. And this has been used to pattern electrode in various devices. And these devices are light emitting diodes, thin film transistors, large electropoietic display, monolithically integrated flexible display of polydispersed liquid crystal. Using this technology, they produce large array of high-performance organic single crystal field effect transistor on flexible substrates. Microcontact printing patterned coiled quantum dots into the multi-layer light-emitting devices and domesticated the multi-layer electroluminescent structures. Okay, now we discuss the next application, that is in micro and nano fabrication. Okay, microcontact printing is commonly combined with other technology to fabricate the micro and nano structure of functional material. It was initially developed to create a mask of wet etching to replace the photoresistant pattern created by the photolithography. The most commonly used masks are self-assembled monolayer of alkaline thiol printed on a gold surface. Metal nanolayer has been produced using this method, printing the DTS monolayer pattern onto the ITO as a whole injection blocking layer of fabricating on organic light emitting dye. Okay, printed multi-layer nanoscale crossbar structure demonstrating the capability of this technology to fabricate the 3D circuit. printed the iron based crystal on SiO2 or Si surface through the carbon nanotube by catalytic decomposition of acetylene. Okay, these are the application of microcontact printing. Okay, this is all about today's lecture. Please follow ITLS Academy on Instagram, Facebook, Twitter, YouTube, LinkedIn, and also get it on Google Play Store. Thank you so much for watching my video. Please like, share, and subscribe ITLS Academy. Thank you so much.